Everyone, and welcome to my YouTube channel. So here today we are going to be continuing our freefall problems. So now we have this type of a situation. We have been told that a hot air balloonist rising vertically with a constant velocity of magnitude 5 meters per second releases a sandbag at an instant when the balloon is 40 meters above the ground, as shown in the figure below. After it is released, the sandbag is in free fall. So firstly, we have been told that it is in free fall, meaning to say the only force acting there is gravity, ignoring the air resistance. So we have the distance from here up to here. We are told that that distance is equal to 40 meters. Now, the way it is, we are going to be able to assume that the sandbag will be able to continue moving up even at the point of release. So to understand this principle, let's imagine that you are in a car. Now you, because you are smart, you're not wearing a seatbelt like that. So now what begins to happen is that, let's say there is a road accident with something, let's say, bigger. So what begins to happen is that as this car is moving like in that direction and this car is moving in that direction, when these collide, this object that was inside here is thrown out in this direction. Because they hit each other, it simply means to say this object that was inside it will be thrown outside like that in this direction. So the same principle can be used to understand the fact that just because the hot air balloon was moving up like that, even the sandbag, at the moment it is released, it will continue to move a bit up because of that understanding. So now it will move a bit up, then starts to come down like that. Now it's in free fall, meaning to say we are just looking at it as if it's a straight line. So now, if we have such type of an arrangement, we are going to, for the sake of simplicity, let us take the height at which it was released to be equal to 0 meters, so that when we consider this as 0 meters, whatever distance we can find for the hot air balloon, let's say if we find 1 meter, we can just add 1 meter plus 40 to give us a 41. So that simplifies our physics. Now the other thing is that since this hot air balloon, since this sandbag will begin to move up, so whatever is going up, let us take it to be positive. That means to say at this point from here going up there, the velocity shall be considered to be positive 5 meters per second. Now, since the gravity is the force that pushes objects down, it shall be considered to be negative g, like that. Then the other thing is that we must understand what we are going to call our displacement. So remember, in the previous video, displacement is the change in position. So that means to say if the sandbag was at the 40 meter mark, then at the final it is the ground. So the displacement, regardless of where it will go, it will still be equal to 40, like that, 40 meters. So regardless of where it goes, the displacement, which is just the difference between the initial position and the final position, even if it goes up, but if it began here, the displacement is measured from where it began and where it is. So with that said, we can now be able to answer the question. So it says that we have compute the position and velocity of the sandbag at 0.250 and 1 second after it is released. So we are looking at the displacement and the velocity. So the equations that we are going to be using are either v squared should be equal to u squared plus our 2as, or we can use our v should be equal to u plus at, depending on how much information we have, or we can be able to use our s should be equal to ut plus half at squared, like that. Now, provided that we want our velocity, we have been provided with time. We can just go direct by using this. So to find the velocity, we can be able to say our velocity, or first let's find the position. So the position, we are provided with time. We know our initial, we know our time, we know our acceleration. It's a gravity. So we can find the position. So the position will be equal to, S should be equal to ut plus half at squared. So our position, S, should be equal to, what is our initial velocity? The initial velocity is equal to 5. So we are going to say positive 5. Then our time is 0.25, like that. 0. Then we have plus our half. The gravity, since it was immediately it's released, it does not immediately go down, but it will still continue to move up a bit, meaning to say our gravity will be a negative, since at that moment it's acting downwards. So negative 9.8. Then we have our time, which is 0.25 squared, like that. So we can be able to simplify this by saying that 5 by 0.25, this gives us a value of a 1.25. Then we are going to have minus our 4.9. Half times 9.8 is 4.9 times our 0.25 squared. This gives us a value of our 0.0625. So multiplying that, so we have 1.25 there. Then we are going to have minus 4.9 times 0.0625. So we are going to have a 0.30625, like that. So our S will be equal to, we are going to have something like, if we subtract our 1.25, there we are going to have a value of 0.94375. So this is the displacement it gains, or rather the position. So it's more like we are saying that from where it was, it has risen 0 point. So from where it was released, it has risen 0.94375. So that is the position. So we can take it to be like this: 0.94375. We can just say above the 40-meter mark. If you don't want this, you can just add 40 plus this to get 40.94375 meters from the ground. So either you can represent it like this, but if you have found your position, you say above the 40-meter mark. Then let us find the velocity. So velocity, we are going to say V should be equal to U plus our AT. Using the same time, we are going to be able to say our V, which is the final velocity, we don't know. Our initial velocity is 5. Our acceleration is negative, so we can put negative 9.8. Then the time taken is 0.25, like that. So we are going to have our 5 minus our 9.8 times our 0.25. This gives us a value of 2.45, like that. So the velocity that we are getting is 2.55. So this is our velocity at that point when the time is equal to 0.25. The other thing is that we have at 1 second, we are going to use the exact same equations. So using this first equation that we used, our S, so we can be able to say at t is equal to 1 second, we can be able to say S should be equal to ut plus half at squared. So our S should be equal to, our initial is 5, then the time is 1, plus our half, our A is 9.8, then our T is 1 squared. So we are going to have our 5. Now remember, our gravity should be negative because the sandbag, when it was released, it was still going a bit up. So we are going to have minus 4.9. 1 squared is 1. So we are going to have 0.1. 5 minus 4.9 will give you 0.1, like that. So this is our displacement in meters. So that means to say it has 0.1 meters above the 40-meter mark. So let's look at our velocity during the same time. So velocity is equal to u plus our at. So the velocity is equal to, the initial is 5, then we are going to have minus the acceleration due to gravity will be negative since the sandbag was still going a bit up, 9.8, then our time will be equal to 1 second. So we are going to have our 5 minus 9.8. If we subtract this, we are going to get 9.8 minus our 5, negative 9.8 for that matter. We are going to get a negative 4.8 meters per second. So if you look at this, meters per second, if you look at this, what this tells you is that the sandbag rose up, then it began to fall. So if it began going up, we know that going up, the initial is 5 meters per second, positive for that matter. But when it starts to fall, it starts to go down, the velocity will assume a negative value. So that's why we have this negative. So it's either you can represent your answer like this, or you can be able to say 4.8 meters per second down. When you say down, that means to say there is no need for you to put a negative. Looking at our B, we are told that how many seconds after it's released will the bag strike the ground. So how do you find when the bag will strike the ground? So remember what we said, regardless of where it went. Yes, it went a bit up, but we don't care about that. The initial position is here and the final position is here. So if this is the 40-meter mark, then wherever it will go, as long as wherever, even if it went up, it will still have the displacement. It will be, the initial position is at 40, then that will be your displacement. No matter, even if it went up there, it gained another, let's say 40, it doesn't matter. But displacement, you just look at where it started and where it's ending, and the separation distance between that is 40 meters. So under that one, now remember, we are taking anything that is going downwards to be negative. That's how come our gravity is negative. So instead of saying 40, we shall say negative 40, like that. So now we want to find out what time it will take. So to find the time, we are going to use this equation. Since we don't have the final velocity, so we can be able to use this equation. We have the displacement, we have u, we don't just have t, we have our a. So we can be able to say, now instead of saying that, using s should be equal to ut plus our half at squared. Instead of saying 40, we are going to say negative 40, since it is below where it was thrown, where it was released. When it was released, it went up. So whatever is below the point at which it was released will assume a negative value. So negative 40 should be equal to, the initial is 5, we put a t, then we have plus our half. Where there is acceleration, we are going to put negative 9.8, it shall be a negative. Then we have our t squared. So reducing this, we are going to have negative 40 should be equal to 5t. Half times 9.8, it will give us negative 4.9 t squared, like that. So taking this value this side, we are going to have a 4.9 t squared. Then we have minus our 5t minus our 40 should be equal to 0. So if you reach this stage, find your value by using the quadratic formula. Since this is squared, this is t, this is a number without t. So we can be able to say t should be equal to negative b plus or minus the square root of our b squared minus 4ac over our 2a. So we can be able to say our t should be equal to negative, our b is negative 5, then we have plus or minus the square root of our b squared. B squared, we have a negative 5 squared minus 4. Our a is 4.9. Our c is equal to our negative 40, like that. So with that, what we are going to get is over our 2a. So our a, according to this is our a, this is our b, this is our c. So our a is equal to 4.9, like that. So we are going to find that negative times negative, it will be positive 5 plus or minus the square root of 5. Negative 5 squared will give us 25. Then we are going to have negative 4 times 4.9 times 40, negative 40 for that matter, it is going to give you a positive 784. Then we divide over our 2 times 4.9 will give us 9.8. Then we are going to have our 5 plus or minus the square root of, we have our 25 plus our 784. So if we add this, we are going to get 809. We divide this over our 9.8, like that. So finding the square root, we are going to have 5 plus or minus the square root of 809. We are going to have a 28.442. We divide this over our 9.8. So now, if you see this value, instead of we cannot subtract because time cannot be negative. If this value was greater than 28.44, it's possible to subtract, but since it is less than this value here, we are just going to add. So we are going to say 5 plus 28.442, then we divide over our 9.8, like that. So adding our 5 plus our 28 points, that we are going to get a value of 33.442. We divide over 9.8. When we find that, we are going to find that our time is equal to a 3.41 seconds. So the time it will take for it to strike the ground will be 3.41, like that. The next question is saying that with what magnitude of velocity does it strike the ground? So remember, we have found the time, it is 3.41 here. So with what magnitude of velocity does it strike the ground? So to find the magnitude at which it strikes the ground, we are going to say, using the simple equation, since we now know the time, we can just use this simple one. Our a we have, our t we have the initial, we have the time. So the initial is just fixed, which is the one it began with, to be our 5 meters per second, like that. So considering that, we can be able to say our v should be equal to u plus our at. So we have everything. So to find the v should be equal to, what is our initial velocity? Our initial velocity is 5. Then we have the gravity. Since it was slightly moving up, the gravity will be negative. So we have minus our 9.8. Then we have the time taken, it's 3.41, like that. So we are going to have 5 minus our v should be equal to, we have a 9.8 times 3.41. So we are going to get a value of our 33.418. So our v should be equal to, if we add our 5 to that value, we are going to get a negative 28.418 meters per second. So now what they wanted was the magnitude. Therefore, magnitude should be given as the absolute value of v, which should be equal to, you just put your number in the absolute value symbol. That means to say we are just considering the positive. When we are looking at the magnitude, we just consider the positive. So we can be able to say 28.418 meters per second. If they just said velocity, it would be okay, because if it's going down, it's just showing you to say it is a negative value since it's going down. So with that said, we can look at our next question. This one, what is the greatest height above the ground that the sandbag reaches? So to find the greatest height, you must know one thing. If a body has reached its greatest height, that means to say the velocity is equal to 0 at the greatest height. So you can be able to say, let's say if a body is moving up like that, the only reason why it would stop moving up is if it loses all its velocity. So at the maximum height, the velocity is equal to 0 because it has stopped moving. If we have something like a 5, it will continue to move up. That's the way it works. So the only reason it stops is because there is no velocity. So at the maximum height, velocity is equal to 0. So if you're asked about the maximum height, you can use for v squared is equal to u squared plus 2as. So most of the times when you have the maximum height, you use this equation if you don't have the time, instead of using ut plus half at squared. So you will use this one because you do not have the time, so you can just go direct. Now using v squared should be equal to u squared plus 2as. Remember, at the maximum height, the final velocity is equal to 0. We have meters per second. We square this, should be equal to the initial. This is the same sandbag, so it began with the 5 meters per second. We square this, then we have plus our 2, then our a is equal to 9.8, then we have our s like that. Then what we are going to get is that 5 squared will give us 25. Then we have our gravity is negative, so negative, we are going to say minus 19.6. Then we have our s like that. So taking the 25 this side, it will be equal to 25.25 negative 25 for that matter. So negative 25 should be equal to negative 19.6 s. We divide negative 19.6, we divide by negative 19.6. Our s value shall be equal to this negative and this negative cancel each other. So we are going to have 25 divided by 19.6. 25 divided by 19.6, we are going to have a value of a 1.28. So 1.28 meters. So this is above the 40-meter mark. So now the question was, from what height above the ground? We are told that, according to the question, we are told that what is the greatest height above the ground that the sandbag reaches? So to find the greatest height above the ground, we are just going to add what we have found. So greatest height above ground, you are just going to say 40 plus this height reached 1.28. This will give you a 41.28 meters like that. So that is how we go about that one. Let's look at our next one. Last but not the least, we are required to sketch a graph of our acceleration AY against time. So how do we, the acceleration, we were using the acceleration due to gravity, which was constant. So what we are going to have is something like this. Let's call this one as our 0. So with as time progresses like that. Now remember, the acceleration is constant. So against the unit of time, if we have the acceleration against time, the acceleration was taking a negative value, which was our negative 9.8. We have the positive 9.8 there, but since we were taking it to be negative, our graph will come out to a straight line that will look like that at the mark of the 40 meter mark, or at the mark of our 9.8 negative for that matter. Now, if we look at our velocity, we have the Vy against the time, the velocity against time. So if you look at your velocity, this is the way it is. Now remember, as it was pushed up like that, the velocity, there was a loss in velocity. So when it was going up there, it was losing velocity. Therefore, it began with the 5 at first. It began with a 5. So it will be able to drop exponentially, because the acceleration is more like, the acceleration is uniform, which is our 9.8. So there will be a steady decrease like that. So it will look like something like this. Now, as you can see, the velocity at the maximum height, so this would be the maximum height, it will be a 0. Now if you look at the arrangement, you will find that when it reaches the maximum height like that, so what we are going to have is that, let's say this is the particle. As it was released, it continued to move up like that. So up, up, up. So now you will realize to say, when it reaches its maximum height, the velocity is 0. So this is the thing that we have here. If the velocity is 0 at that point, we are going to be having something 0 here. Now it begins to drop. So as it begins to drop again, the velocity there is again. Now, due to the fact that it is dropping, the velocity will assume a negative value. So the increase is there, yes, but it will be in the negative direction. So therefore, we can continue like that. So this is how we are able to draw such a graph. So this is the graph of, we can say, velocity against our time like that. So this is how we can draw that graph. So let's just find the time it will be at its maximum height, using v should be equal to u plus our at. So we know that our final is 0 should be equal to, our u is equal to 5. We have minus the 9.8, then we have the time. Then taking the 5 here, we are going to have negative 5 should be equal to negative 9.8 t. Divide negative 9.8, divide negative 9.8, which will give us a value of t should be equal to a 5 divided by 9.8. So this value is equal to a 0.51 second. So we can just attach this to our graph to say 0.51 second like that. So then we are going to be looking at our last graph, which is our y against time. So y, which is the displacement, so y against time. So if you recall what we said, we have the 40 meter mark somewhere. So let's say this is our 40 meter mark. Remember, when the bag was released, it was going a bit up like that. So what we are going to have in the graph is that it will still go slightly above it will slightly go above. So we are going to have something like this. So it will go above. So this is the sandbag. It will go above to the maximum height, which we found to be 41.28. So it will go slightly above. like that above the 40-meter mark, then it will begin to drop. Now remember, the time at this point is such that at the maximum height, the time it is 0.51 seconds, like that. Then we found the time it will take for it to strike the ground to be 3.41 seconds. So you can use those for your details. So this is our time in seconds. Then this will be our y. Now remember, y, we are talking about the vertical distance for free fall. So that is how we can graph those problems. Thank you very much for watching. Hope you would like, subscribe, and share for more. See you in the next tutorial.